Looking at equivalent trig expressions, and we're kind of focused on, they name it co-function formulas. Your teachers called it equivalent trig expressions, and they have a set of 6 where you guys have 12, and their only difference is that when cos pi over 2 minus some angle x, or theta in this case, is equal to negative sign, then the sign here changes, and then you can build a whole extra 2 sets of these by doing all of those that same way. So with that in mind, they've given us what sine pi over 5 is equal to. They want us to calculate essentially using pi over 5 sine. So we need to somehow make this a function of sine instead of what we have right now. So what we're going to do here is we're going to split our expression in the middle. We have 3 pi over 10, and we want to get essentially 2 values that will either add or subtract, because in here, all of these are actually subtraction values. Okay, so for these 6, it would be best if we found 2 values that subtract to equal this. But if we were to find 2 values that say added, the only difference with these would become essentially negative ideas. Whoops. Okay, so we can think of 2 values that will subtract to this, and one of the values, essentially what we want one of the values to be, is one of the values we need to essentially be equivalent to pi over 2, and the other one kind of the equivalent of pi over 5. So in this case, we're dealing with a denominator of 10. So another function that would work well, we could always write, let's write it over here, sine 2 pi over 10 is the equivalent of this value also. So this might be a number we want to use when we're taking 2 terms that will equal this. Okay, and if we have pi over 2 as one of the values we need in order to actually get an equivalent co-function formula, pi over 2 with a denominator of 10, well, that would be the value of 5 pi over 10. Okay, and the reason I've done that is because I need this value and this value in my expressions to equal this. So if we take a look at this, if I have 5 pi over 10 and 2 pi over 10, can I use an operation that will make 3 pi over 10? Can you think of an operation that would
subtract 2 pi over 10?
Yeah, exactly. So if we do 5 pi over 10 subtracted by 2 pi over 10, okay, still the exact same function, it's still a cos function, okay. What this does now is this gives us 2 values that we can work with, because they've told us what this is equal to, and we didn't want to use a calculator for it. And in our functions here, we're working with pi over 2. That's really important for us. So just to make it a little clearer, I'm going to convert this to pi over 2, and I'm going to convert this to our pi over 5, okay. And essentially what I mean by convert is just we're going to change the denominator of the fraction. So we have cos, and this is equal to pi over 2. Okay, subtract, and this is equal to pi over 5. Okay, so now that we've done this, this works out great. We're going to look for something that's equivalent, and it just so happens the one I've been underlining the whole time is the value that will work out perfect. This would be equal to sine, and then would be pi over 5 in this case. Okay, so, and if you're unsure how I did that, I'll write the formula out in underneath. So we had cos pi over 2 subtract theta is equal to sine theta. So what we did here is once we got our equivalent pi over 2's, okay, so once those two are the same, we know that this other value must be our theta value. And if that's our theta value, what that means is an equivalent expression would be replacing that theta on the right, where sine theta is. And in this case, we have sine pi over 5. And we wanted it to be very exact. We wanted pi over 5 because of the way this expression was given at the beginning. They told us exactly what it was equal to. But in many other instances, it's not something that we have to do. We don't have to use this value, but the very first value, the pi over 2, is something we usually want to work with when splitting these up, especially if we're working with these formulas here, because all of them involve some form of pi over 2 in their expressions.